Okay, students, here we have the backside of the review for the polynomial test. Okay, we've done these questions before. For what value of m, right? So we're going to have algebra. Will x equal to have a remainder of 9 for this polynomial? So notice what we're missing here. We have an x to the fourth, we have an x third, we have an x squared. We have no x term. So when we do our synthetic division, we're going to put a 0 in between the m and the 5. Okay, so synthetic division, we have 1 minus 3. We have our m when we have 0 and we have 5. And I'm putting a lot of space in between there because I know there's going to be some type of an equation going on. And we're going to use 2 as your synthetic divider. So 2's on the outside, all of your coefficients are on the inside. We want the remainder to be equal to 9. So whatever is going to be here, I need to say that needs to equal 9. Okay? That was part of your free response. If you had it set equal to 9, you got a point. So let's drop down the 1. 1 times 2 is 2. That's negative 1. Is a negative 2. So here where we have your first equation, m minus 2. Okay, m minus 2. And now we're going to multiply both of these parts by 2. So we're going to get 2m minus 4 when you multiply both of those parts. Right, plus 0 is another 2m minus 4. And now I'm going to multiply both of these parts by 2 also. So 4m minus 8. Okay, and when I add this together, I get 4m minus 3. Okay, so that's my remainder, 4m minus 3. And that needs to equal 9. So hopefully the algebra here is not too hard for you to do. 9 plus 3 is 12. Divide both sides by 4. And if I had an m value of 3, that means my remainder, when I synthetically divide by 2, would be 9. Okay? It gives you the specific one that we need to have, 9. If it says if it's a root, what will make this a factor, then we want a remainder of 0. Okay, so you would set it equal to 0 if this were going to be a root or a factor. Okay, so hopefully you're okay with that kind of stuff. There's one on your test. Okay, what does the multiplicity of a root have to do with the graph of a polynomial? Right, there's a poster that you guys have seen for weeks, maybe more than 1 week, but there's 3 different types of multiplicities. There's a multiplicity of 1, where your graph crosses the x-axis normally, right? Crosses your x-axis normally, right? Kind of vertically at a normal rate. What you usually see, okay? Normal graphing. What if we have a multiplicity of 2? Okay, in that case, then the graph will bounce on the x-axis. Okay, it will not actually cross the x-axis. It goes from one side, bounces, and goes to the other on the same side. Okay, it bounces on the x-axis, does not cross. Okay, it does not cross the x-axis. And then if I have a multiplicity of 3, right, I have a 3 as the power, then the graph will cross, but the graph will flatten, right? It will not be very vertically, it will be very flat as it crosses the x-axis. So if we have an odd multiplicity, the graph crosses the x-axis. And if we have an even multiplicity, the graph bounces on the x-axis. And we use that information of multiplicity in graphing when we do a sketch. So this one says make a sketch. Let's figure out all these things that we're going to be involved in our sketch. Okay, the zeros. This one gives us a 0. This factor gives us a 0. and this factor, right? Everything that is being multiplied gives us a 0. So we have x equals 0 from our x squared. We have x equals positive 6 from your x minus 6. And we have, I don't want to do it in green. Yes, I'll do it in this color, green. And we have x equals negative 4 from our x plus 4 factor. Okay, now each of these has its own multiplicity based upon its power. So our x has a 2. Your x minus 6 has a 3 as its power. And your x plus 4 only has a multiplicity of 1. Okay, so at 0, the graph is going to bounce because that's what a multiplicity of 2 means. At 6, the graph is going to flatten as it crosses. And at 1, the graph is just going to cross normally. Now the end behaviors, okay, they come from as, let's see, x goes to the left of the graph. What are the y values doing? And as x goes to the right, what are the y values doing? Okay, so that comes from the fact that this is a, let's see, 2 plus 3 plus 1, right? These are the multiplicities. That means this is a 6th degree polynomial. Okay, so a 6th degree means it's an even polynomial. And the minus in front means it's going to be a negative. Okay, so we're looking at a negative even polynomial. So both of our arrows point down. So they're both going to go to negative infinity. It's an even negative polynomial. Okay, even because the sum of the multiplicities, 2 plus 3 plus 1 is 6. 6 is an even number. There's a negative in front of our first factor. So it's a negative even polynomial. So both of your arrows point down on the lower left and the lower right. Okay, so down here and down over there, because it's negative. So let's see, we're going to put in our minus 4, right? Here's a negative 4. 1, 2, 3, 4. That's where it crosses the x-axis. It crosses the x-axis at 0. And it crosses the x-axis at positive 6. 1, 2, 3, 4, 5, 6. Okay, so those are your 3 zeros. So we put them on. The graph will cross at negative 4. So it's going to come up like this, cross at negative 4, turn around, and then bounce at 0. So it's going to go back up a little bit, and then it's going to cross in a flattening manner over here, something like that. Okay, so remember, it doesn't have to be perfect. We don't need to know what this maximum is or what this maximum is, just so that where it crosses, we're crossing kind of vertically. It bounces at 0, and it crosses flatly at positive 6. Okay, so be able to graph, right? Make a sketch of the graph based upon your zeros and their multiplicities and the polynomial end behavior. All of those wonderful things. Okay, and then this is pulling all of it together. We're told that we have one root. So it says to find the other factors, find the zeros, and then sketch. Okay, so we find the other factors with synthetic division. We use the one root that we have and synthetic division to find our quadratic. Okay, so if I divide an x cubed, I'm going to get an x squared as an answer. So 1, 1, minus 8, and minus 12. Because notice, this is not factorable by grouping. Right? There's nothing in common here that we have over there. So we can't factor this one by grouping. So we're going to use synthetic division to find out what the quadratic is going to be. So positive 2, that's a negative 6. Positive 12 is a 0, just like we would expect. So now these three numbers represent the coefficients of our quadratic 1x squared minus x minus 6. Okay, so you do synthetic division with -2, and then you use your three remaining terms and you create a quadratic. Okay, that's the quotient. So now we're going to factor this quadratic. What numbers multiply to give us -6 and add to give -1? -3 and +2. So we can factor this to x minus 3 and x plus 2. Right? That comes from your quadratic right here. This quadratic factors to these two terms. And we still have to remember our first root up here of x plus 2. Okay, so this is completely factored. We have three factors. So what are our zeros?
X equals 3, x equals -2.
So a -2, a +3, and a -2. So guess what you should be noticing? That there are two of the same zero. Two of the same zero, which means that this -2 has a multiplicity of 2. Right? Literally two of the same number. And 3 only has a multiplicity of 1. It's its own root all by itself. Okay, so this is going to tell us that at -2, the graph is going to bounce. And at +3, the graph is going to cross. Okay, two of the same zeros. We have -2 repeated twice. So we have a multiplicity of 2. So when we come to our graph, -2 is right here, and +3 is right here. Those are both zeros. Right? We have a positive odd polynomial. Okay, it has a +3, right? There's no minus, which means it's a positive. And our highest power is odd. So that means it's going to start in the third quadrant and end up here in the first quadrant. Right? Those are the end behaviors. So it has to bounce at -2 and it will cross at +3. Okay, so somehow we make our graph come up towards -2, right? Touch and go back down, and then turn and go up through +3 and up forever. And put in your arrows. Okay, so I'm not really concerned with how far it goes down. Right, it can't cross, so it should only touch right here at -2, and it should cross once at +3. Okay, so there it is, all of it put together. That's as much as you're going to be asked to do with the graphing and figuring out an m value for synthetic division. Okay, make your test help sheet on that blue piece of cardstock, and do your best on your test. Goodbye.